So in the last class, we have discussed this last question.
Yes.
This question I have discussed. Today we will discuss the energy density of the electromagnetic wave. Energy density of electromagnetic wave. What is the meaning of energy density? Energy density is basically energy contained in a unit volume. If you are taking a cube of 1 meter cube and the energy contained in that uh, cube will be the energy density. Basically, energy density is energy divided by volume. Okay.
Okay.
Energy divided by volume. And we have seen here in electromagnetic wave, energy is carried by the electric field as well as the magnetic field.
Yes.
Because in electromagnetic wave, what are the fields? Electric field and magnetic field are there. And electric field and magnetic field are oscillating perpendicular to each other. The electric field and the magnetic field are oscillating perpendicular to each other. You can see here.
Yeah. Yes.
Okay. Here we have just considered that electric field is along y direction, magnetic field is along z direction, and the wave is propagating, or you can say the motion of the wave is along the x direction. But there can be there can be another direction of the electric field also, magnetic field also, and the direction of the propagation of the wave. There
Yes.
can be there can be a wave in which the electric field can be along z direction or magnetic field can be along x direction. So depending upon the uh, observer, okay, what
Yes.
he or she is considering. So basically we have considered that electric field is oscillating in y direction, magnetic field is oscillating in z direction, and direction of the propagation of the wave is along x direction. So you can see here the electric field. What is the meaning of the oscillation? Oscillation means, suppose this is a point here,
Yes.
this is a point here, okay, and
Okay.
just a minute. So suppose this is a point. Suppose this is a point, and this is the mean position of the point, and this point is going up
Yes.
and down, up and down. Suppose this is the mean position. From here, the displacement of the point is increasing.
Yes.
This is the mean position. From here, the displacement of the point is increasing. Now, displacement is decreasing.
Yes.
Okay.
Okay.
Basically, see, this is the reference point.
Yeah.
This is the reference point, and you can just consider this is the mean position. And now here is a particle. This is a particle. Suppose initially
Yes.
the particle is here, and now this particle is going in the positive direction. So the displacement of the particle is increasing.
Yeah.
Now this particle is coming in downward direction. Now
Yeah.
displacement becomes zero.
Zero.
Then again it is going in negative direction.
Negative direction. Yes.
In negative direction, the displacement is increasing, and finally the particle is
Yeah.
moving up, and finally the displacement is zero. And this is the
Yeah.
same case with the electric field and the magnetic field. It's oscillating like this. Electric field and magnetic field both are oscillating. So you have to understand what is happening here. Basically, electric field and the magnetic field is oscillating, and this is the graph. This is the electric field. Here you can see first see only the electric field here. The first the electric field is increasing
Yes.
like this. From here to here, the electric field is increasing. In which
Yes.
direction the electric field is increasing? Along the y direction.
Yeah.
Along the positive y direction. Now
Yes.
from here, see, the electric field is
Decrease
decreasing.
to negative y. Yeah.
No. Again, the positive y direction. Negative y direction will be below this axis.
Yeah. Yeah.
Negative y direction will be this direction. If you are saying that negative y, so negative y will be this direction. Okay.
Okay.
So below this axis will be the negative y. Okay, this will be
Okay.
the negative y direction. So from here to here, the electric field is increasing in positive y direction, and from
Yes.
here to here, the electric field is decreasing in
Yes.
positive y direction. In
Yeah.
positive y direction. Now from here to here, see the length of the arrows. Here to here, the length of the arrows are increasing. So means
Yes.
the electric field is increasing, but this time the electric field
Negative
is
y direction.
increasing in negative y direction.
Yeah.
Okay. Now
Okay.
see from here to here, again the
It's
electric field is decreasing in negative y
decreasing.
direction. And
Yeah.
okay, this is the first case. Now
Yeah.
see the magnetic field. Electric field vector, electric field and the magnetic field are perpendicular, and same is the case of oscillation with the magnetic field. Okay, magnetic field is also oscillating like this. Okay, first increasing, then it becomes maximum, then decreasing, then increasing in negative direction, then again decreasing and becomes zero. Oscillation means this thing. So energy density of electromagnetic wave, basically in electromagnetic wave there is an electric field and magnetic field, and electric field and magnetic field are oscillating. What is the meaning of oscillating? The electric field and the magnetic field are changing in magnitude as well as direction with
Yes.
respect to time.
Yeah.
Okay, so here are the energy density of the electromagnetic wave, and 3 points are there. I have written. So electromagnetic waves carry energy, electrical energy and magnetic energy, as they travel through space. Okay. Thus, energy is contained in oscillating electric and magnetic field. Clear? Second
Yes.
point. Equal amount of energy is contributed by electric and magnetic field. This we will prove later. There are equal amount of energy. There are equal amount of energy contributed by the electric field as well as the magnetic field. Okay. The
Okay.
energy of the in electromagnetic wave, the energy of the electric field as well as the magnetic field are equal. So these points we will prove later. Okay. Next point. Why now we know that the electromagnetic wave is produced by the oscillating charge. I have told you na, electromagnetic wave is produced
Yes.
by
Yes.
the accelerating or oscillating charge, and from where we get the oscillating charge? In LC circuit. In LC circuit, LC circuit means inductive and capacitive circuit. When you
Yes.
are connecting an inductor and a capacitor in series, and in that circuit there is a charge oscillation is there due to the energy difference. The energy of the electric field is from the capacitor. So from the capacitor, what type of energy is there? Electrical energy is there, and energy of magnetic field is from the inductor. Okay.
Okay.
Now energy density. Now this is the energy density. Now we will calculate the energy density of the electric field. Energy density of the electric field. Okay.
Okay. Sir.
Uh, energy density of electric field. Okay. So energy density of electric field I will represent with small u suffix e.
Okay.
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 This thing we have studied in the capacitor. Basically, these are the two plates of the capacitor, and this capacitor is is in the charging condition. We have discussed this thing now. So on this plate there is a negative charge, and on this plate there is a positive charge. And I have told you there will be the electric field in between the plates of the capacitor, and these plates are separated at a distance of d,
B.
small d. These
Mm.
are the plates of the capacitor, and this is the electric field. And why there is an electric field? Because of this negative charge and this positive charge.
Positive. Yeah.
And during the charging of the capacitor, what happens? This charge on the plate increases, and due
Yeah.
to the increase in the charge, the electric field increases.
Yeah.
Basically, here this electric field is changing with time. This
Yes.
electric field is changing with time. Okay. Now energy density in case of the capacitor is given by half epsilon naught into E square. In the electrostatics, in chapter potential and capacitance, electrostatic potential and capacitance, this formula there in we have studied, or you have studied, half epsilon naught into E square. This is the energy density of the electric field. Okay, this is the energy density of the electric field. And where the energy, where is the electric field? Electric field is contained in between the plates of the capacitor. Okay, energy density
Okay.
of electric field. So basically, this is the uh, electric field. Well, basically, what we are doing, we are just calculating the what is the energy density of electric field. We are calculating. Okay. So electric field we have considered in between the plates of the capacitor. This is the electric field, and this capacitor is in the charging condition. Okay. So energy density of the electric field is given by this. Okay. And we know that the electric field is changing. Electric
Yeah.
field is changing with time. Okay, and the equation of the electric field I have written earlier, E is equal to E naught sine kx minus omega t. E is equal to E naught sine kx minus omega t. So now what we will do, suppose this is your equation number 1. This is your equation number 1. Okay, and this electric field is variable or not? Electric field is variable, so we will put this
Yeah.
value here.
Yes.
So okay, so UE can be written as half epsilon naught E naught E square. E square, so means this is square. So it will become E naught square, and this is sine square kx minus omega t. This is the value. Basically, this is the energy density of the electric field, and this energy density of the electric field is changing with time due to change in the electric field. Okay,
Yes.
here is time. This time is changing, and this x is also changing. So that is why this energy density is changing. So now what we will do, we will take the average value. We will take the average value of the energy density. When something is changing with time, we take the average value. Na? Like current is
Yeah.
for the current changing, we take average. We calculated average value of the current. Okay, so average value we will take. So take the average of this. This symbol is representing the average. This bar means the average. And I have told you the average value of sine square theta for any value of theta is equal to half. So average energy density, you will get half epsilon naught. This half epsilon naught is constant, and E naught square is also constant. And the average value of sine square any theta is equal to half. So this is half. So basically the average value of energy density, you will get 1 by 4 epsilon naught E naught square. So this is the average value of the energy density for the electric field. In the same way, we can calculate the energy density for the magnetic field. Okay, this is the average value of the energy density. What is E naught? E naught is the peak value. E naught is the peak value of electric field.
Yes.
And epsilon naught, I have told you, epsilon naught is the absolute permittivity of free
Yeah.
space. So this is the energy density of the electric field. So energy density of electric field is in between the plates of the capacitor, and we have calculated like this. Now, where will be the energy density of the magnetic field? How can we calculate the energy density of magnetic field? I have told you there is a inductor, and
Yes.
energy stored in the inductor is in the form of the magnetic energy.
Yes.
Energy stored in an inductor is the magnetic energy is in the form of the magnetic field. Okay, so basically energy density of magnetic field is same. So basically this is a solenoid, or you can say an inductor. In this there is a current I and length L, and the magnetic field is like this, and R is the radius. So basically the energy density of the magnetic field, this also I have derived later earlier when we were discussing that chapter,
Yeah.
electromagnetic induction.
Yes.
I have derived there, na? Okay. So energy density of the magnetic field is half epsilon naught into V square. This is the formula. What is U suffix V? U suffix V is the energy density of magnetic field. Energy density of magnetic field. Now we have written the this is the magnetic field, and this magnetic field is also changing with time.
Yeah.
By this equation, we have written what is the magnetic field equation. Magnetic field equation is this: V is equal to V naught sine kx minus omega t. Okay.
Okay. Yeah.
So magnetic field here also changing with time. So when you will put this value of the magnetic field, and same way you will take the average. Okay. Same way you will take the average, and the value of sine square any theta is half. So you will get this value 1 by 4 mu naught into V naught square, average value of the energy density of the magnetic field. This will be the average value of the energy density for the magnetic field. So this formula also, okay, I will tell you later what you have to remember. Okay.
Okay.
So this is the energy density of the magnetic field, average value of the energy density, because here the energy density of the magnetic field is changing with time.
Yes.
Is changing with time according to this equation, because the magnetic field is also changing with time. Okay.
Okay.
So energy density of the magnetic field. Okay. Earlier I have already derived this equation. Earlier I have already derived this equation. If you want to see, you can see here in the EMI. Just a minute. So I am showing just a minute. So energy density for the inductor, you can check your notes if you want. There we have covered this topic, energy density for the inductor or solenoid. This basically, this is also the energy density of the magnetic field. So basically what result we get? This result we get, energy density. Okay. So directly I have used this result there. Okay.
Okay.
This is the derivation. If you want to go to the derivation, you have to check your previous notes.
Okay.
Now, in an electromagnetic wave, there is a electrical energy, or you can say electrical energy density, and the magnetic energy density. In an electromagnetic wave, there will be the electrical energy density and the magnetic energy density.
Yes.
Okay. Now we will see whether both the energy densities are equal or not. Basically, both energy densities are equal, because I have told you here uh, equal amount of energy is contributed by electrical magnetic field to the electromagnetic wave. So now we will see whether the electrical energy density, and we will take the average value, is equal to the magnetic field, magnetic energy density. Okay, so basically this is the total energy density of the, basically U is the total energy density of electromagnetic wave. Total energy density. This is the total energy density. Okay. We want to see whether what is UE? UE, and here we will take average because this UE will be changing, and that is why we have taken the average. This is the
Mm.
average energy density of electric field. Density of electric field, and UV average is basically the average energy density of magnetic field. So in an electromagnetic wave there is a electrical energy density and magnetic energy density, and total energy density is given by this. Okay, now we will see whether this UE is equal to UM, or you can say UV also. This is UV basically. UV is the magnetic energy density. We will see this equation. What is the, now we will start from this. UE average is given by half of 1 by 4 of epsilon naught into E naught square. 1 by 4 epsilon naught into E naught square. Just I have proved that the average energy density for the electric field, you can see here, average energy density for the electric field is 1 by 4 epsilon naught into E naught square. E naught is the peak value.
Yes.
So just I have written this. Now and there is a relation between the electric field and the magnetic field is equal to C. This is
Yeah.
the relation. Ratio of the peak value of the electric field divided by the magnetic field is equal to C. C is the speed of light. Okay, so we can write this half into epsilon naught. Instead of E naught square, I can write this is E naught. E naught is equal to C times of B naught. So instead of this E naught square, I can write C square into B naught square.
Yeah.
So I can write B naught square into C square. Now there is a relation. C is equal to 1 upon under root mu naught into epsilon naught. This is the relation we
Yes.
have discussed now in this chapter. This
Yes.
relation. Now value of the C we will put here. So this will become half of epsilon naught V naught square, and instead of C square, when you will do the square of the C, you will get 1 upon mu naught into epsilon naught. You will get 1 upon mu naught into epsilon naught.
Yes.
Now this epsilon naught cancel out. So what you will get? You will get 1 by 4 of mu naught into V naught square. And what is this value? 1 by 4 of mu naught into V naught square. Now you can see here, this is the energy density of the magnetic field. 1 by 4 of mu naught into V naught square. What is UV average or energy density of the magnetic field?
Yes.
So basically, this is equal to UV average. So can we say that both values are equal? So can we say that
Yes.
the energy density of the electric field average value is equal to the energy density of the magnetic field average value?
Yes.
We have proved that. Okay. Now if you want to calculate the total energy density, of the magnetic total energy density of the electric field, electromagnetic wave. Total energy density of electromagnetic wave, we know that uh, basically here we will take the average values. So average value of the electric field plus average value of the magnetic field or magnetic energy density. Both are equal.
Yeah.
Both are equal. So I know that this value is equal to this value. So I can write this as 2 times of UE into average. Okay, so I can write 2 into
Okay.
half of epsilon naught into 1 by 4 of epsilon naught into E naught square. So it will become 1 by 4 of epsilon naught into E naught square. So basically it will become total energy density of total average energy density of the electromagnetic wave is given by 1 by 2 of epsilon naught into E naught square.
Yeah. Yes.
So basically this is the total energy density, remember.
Okay.
So in the last I will tell you which formula you have to learn basically.
Okay.
Now there is another way. Basically, this is the one way. This is the one way, and another way is total energy density can also be written as 2 times of energy density of the magnetic field. Okay, so 2
Okay.
into what is the average magnetic energy density? 1 by 4 into mu naught into V naught square. So it will become the total energy density of the electromagnetic wave is 1 by 2 of mu naught into V naught square. Okay.
Okay.
Okay. So basically, this formula you have to learn. These both the formulas you have to learn. Okay.
Okay.
Total energy density in terms of the electric field and in terms of the magnetic field. If someone is asking, if someone is asking basically the what is the energy density of the electric field, then you will say half of the total energy density. Okay, so
Okay.
basically I am writing what I want to say uh, here. Energy density of the magnetic field is equal to energy density of the electric field is equal to half of the total energy density. Okay, and remember the formula of the total energy density. If someone is asking the electrical energy density, then 1 by 2 of the total energy. Okay,
Okay.
depending upon you in what way you are just. So this is the way to learn. And basically this UV is, I am talking the average value. Okay, here UV is the, I am talking to the, I am talking this is the average value.
Okay.
So basically this is the average value. All these energy densities are the average energy densities. Okay.
Okay.
This energy is also the average total average energy of the electromagnetic wave. So total energy of the electromagnetic wave is given by the average energy density of the electric field plus the average energy density of the magnetic field. Now, one question corresponding to this topic. They are saying a magnetic field in a plane electromagnetic wave. So, in an electromagnetic wave, what are the energies? Electrical energy and magnetic energy are there.
Yeah.
Okay. So, basically, it is given in the question a magnetic field in a plane electromagnetic wave is given by. This time the equation of the magnetic field is given.
Yeah.
This time the equation of the magnetic field is given. Find the average energy density corresponding to electric field. So basically what they are asking the energy density corresponding to electric field, or you can write in terms of the average value.
Okay.
So now this equation is given to us. This equation is given. Now, can you tell me what is B naught? B naught. B naught means this. This value will be the B naught. Okay, because the equation is always in the form of E is equal to E naught sine omega t. B is equal to B naught. So this value,
Okay. Yes.
this 200 micro Tesla is B naught. Okay. Now, can you tell me what is the omega? What is omega?
4.0 into 10 raised to minus 5.
Yeah, very good, very good, very good. And can you tell me what is K?
K.
Huh. Okay, okay, no problem. Just I am modifying this equation. Then you can tell. Basically, we can write this equation as V is equal to 200 micro Tesla
Yes.
sine of, and we can multiply this value to this bracket. So it will become 4 into 10 to the power 5. 4 into 10 to the power 5 second inverse into T. Okay.
Okay.
And minus this will become 4 into 10 to the power, it is minus 5 into second inverse into x, second inverse by C into x. So in the last class, what I have told you, the value with T will be omega. Okay, the value with T will be omega.
Yeah. Okay.
And the value with x will be K. So this whole value will be K.
Okay.
Basically, this omega is given by 2 pi by T, na?
Yeah.
So basically, from the unit also you can 2 pi do not have any unit. This T have the unit second, so unit of omega will be second inverse. So it is here also the second inverse. By the way, this is omega, this is K.
Okay.
Now we want to B naught is this.
Yeah.
And can you tell me in which direction this wave is going?
Positive x direction.
Very good. Positive x direction. Okay, we want to find the UE, means this energy corresponding to the electric field. So I have told you how to remember the energy corresponding to electric field, that is equal to half of the total energy. Half of the total energy, na? So half, what is the total energy? What is the total energy? Half, here total energy is half of epsilon naught E naught square.
Yeah.
Okay. Half of epsilon naught E naught square. Now there is a relation between E naught and B naught. This is equal to C. So from here E naught value can be written. So it will become 1 by 4 times of epsilon naught into E naught. Instead of this E naught square, we can write C square into B naught square. Now all the values we have. 1 by 4 epsilon naught is given by 8.85 into 10 to the power minus 11. What is the value of C? C is the speed of the light or electromagnetic wave in vacuum. 3 into 10 to the power 8, and this is square of this.
Yeah.
And V naught square means 200 micro Tesla, 10 to the power minus 6 and square of this. Basically, on calculation, you will get 8 into 10 to the power minus 3 joule per meter cube. So this will be the energy density corresponding to.
Okay, sir.
There is another way also to solve this question. You can just solve this question. The energy associated with the electric field is equal to the energy associated with the magnetic field. This is equal to 1 upon 2 mu naught into V naught square. So 1 upon 2, what is the value of mu naught? Mu naught is given by 4 pi into 10 to the power minus 7. And now put here value of V naught. V naught is 200 into 10 to the power minus 6 square. Same answer you will get. 8 into 10 to the power minus 3 joule per meter. So depending upon what you are doing, means in what way you want to solve the question. In this way also, you can solve the question.
Okay, sir.
Now simple topics we will have. This chapter will be finished, and
Okay, sir.
you have to write from here. Just a minute. Now take the screenshot.
Okay, sir. Done, sir.
Done. Okay. So next slide. Just a minute. Okay. Now you can take the screenshot. And what is this? This is the capacitor plates.
Yeah. Done, sir. Done, sir. Done, sir. Done, sir. Done. Done, sir. Done, sir. Done, sir. Yes.
Okay. So this is the. Now after that we will discuss the intensity of electromagnetic wave. So what is the meaning of the intensity? Basically, intensity is the energy per unit area per unit time. Energy per unit area per unit time means suppose here I have taken, just a minute, I am just giving one example. There is a difference between the energy and the intensity. So basically this is the area of 1 meter square,
Yeah.
and here is this light. Okay, light energy is falling on this. Okay,
Okay.
light energy is falling on this. Now this area, suppose of 1 meter square, the amount of energy that is crossing this 1 meter square area in 1
Yeah.
second is equal to the intensity of this light at this point. Now intensity of electromagnetic wave is very simple, means The energy crossing per unit time per unit area in a direction perpendicular to the direction of propagation is called the intensity of wave. Okay, and
Okay.
intensity of the wave is given by I is equal to energy, u is the energy, basically u is the energy, u is the
Yes.
energy, and a is the area, this area. So we will derive this whole expression. Okay, we will derive this whole expression. Okay, so this is the intensity.
Yeah.
So basically, this is the definition of intensity. The energy crossing per unit area per unit time perpendicularly is the intensity. So now imagine a cylinder here. This is an imaginary cylinder. Okay,
Yeah.
this cylinder is the imaginary cylinder. Imaginary cylinder. And the electromagnetic wave is simply light is an electromagnetic wave. So
Yeah.
electromagnetic wave is crossing this cylinder, crossing the area of this cylinder means electromagnetic wave is entering in this cylinder,
Yes.
and this electromagnetic wave is entering at t is equal to 0, and at t is equal to t, this electromagnetic wave is leaving. Means the energy crossing, we are only interested, the energy entering at t is equal to 0, and the amount of energy that will be contained in the cylinder at t is equal to t.
Yeah.
So we have just choose a time interval from 0 to t. In that time interval, we are seeing how much amount of energy is uh, entering in this cylinder and how much amount of energy is contained in this cylinder. So basically, electromagnetic wave. This is the electromagnetic wave, and here is no medium. So there is complete vacuum. So the speed of the electromagnetic wave is given by c. C is the
Yeah.
speed of the electromagnetic wave in vacuum. Okay,
Yes.
c is the speed of electromagnetic wave in free space. You can say in free space. Now, from time t is equal to 0 to time t is equal to t, from time t is equal to 0 to time t is equal to c, the distance that the electromagnetic wave will cover is equal to this speed into time. Speed of the electromagnetic wave is c, t is the
Yeah.
time.
Yes.
Okay.
Okay.
So this distance will be covered by the electromagnetic wave. First thing, this thing should be clear. And area of the area of the cylinder is A.
Yes.
Area of the cylinder is A, so we can find the volume of the cylinder. So we can find the volume of the cylinder. The volume of the cylinder is area into length of the cylinder.
Yeah.
So the volume of the cylinder is given by area. What is the length? This distance is the length
Yeah.
CT. ACT
Yes.
will be
Yes.
the volume of the cylinder. So
Okay.
basically, this is the volume.
Hmm.
Okay. Now in time t, from t is equal to 0 to t is equal to t, uh, in this volume of the cylinder, we will calculate how much amount of energy is there. How much amount of energy is there?
Okay.
Now, can you tell me that in 1 meter cube of volume, how much will be the amount of energy? Earlier, we have calculated the energy per unit volume of the cylinder. Energy per unit volume of the cylinder. Basically, energy per unit volume of the cylinder is equal to the energy density of electromagnetic wave. Ziyad, are you getting what I am saying?
Hmm.
Basically, just a minute. Actually, just I have derived the thing that energy density of electromagnetic wave. Energy
Yeah.
density of electromagnetic wave means that in unit volume, in
Yes.
1 meter cube or in unit volume, how much amount of energy is contained.
Yeah.
Now, in unit volume of the cylinder, the amount of energy contained will be the energy density of the electromagnetic wave. Energy density of the electromagnetic wave. Okay, I
Yes.
am writing here. Okay, so it will be the so don't get confused. All things are related to each other. Okay, but you have to just apply your mind. Energy density in a unit volume of cylinder is equal to the energy density of electromagnetic wave.
Okay.
Energy density of electromagnetic wave. And that what is the energy density of the electromagnetic wave? Half. In terms of the electric field, you can write half epsilon naught into E
Yes.
naught square.
Yes.
E naught square. So basically, this is the energy in the unit volume of the cylinder. In total volume of the cylinder, what will be the energy? This thing multiplied by the volume of the cylinder. Okay. So
Okay.
total energy filled inside the cylinder from T is equal to 0 to T is equal to T will be this you can write with capital U. This is the total energy. Okay. Basically, this U is the capital U. So capital U is representing the total energy. Okay, total energy. So total energy in the cylinder from T is equal to 0 to T is equal to T having a volume ACT will be energy density of the energy density of the electromagnetic wave multiplied by the volume. Okay.
Okay.
Now what is the energy density of the electromagnetic wave? Half epsilon naught into E naught square.
Yeah.
What is the volume of the cylinder? See on the screen and tell me where is the volume written? This is the volume, na? This term.
Yeah.
So basically, volume is ACT.
Yeah.
ACT multiplied by A into C into T. So basically, this is the energy. This is the total energy contained in the cylinder. This is the total energy contained in the cylinder
Yes.
in time T.
Yeah.
Okay. So basically, this is the energy, or you can say this amount of energy, or you can say this amount of energy is crossing this area perpendicularly in a time interval 0 to T. So you can write this much energy passes perpendicularly from surface A. What is A surface? This surface is a A surface. Okay, this surface is a A surface. Area of the cross section of the cylinder. This much amount of energy passes perpendicularly from surface A in time T. Now intensity we can find very easily. Intensity is basically the total energy contained in the cylinder divided by the area from the area from which the energy is crossing multiplied by the time in which the energy is crossing. What is the total energy? Half epsilon naught E naught square.
Yes.
Multiplied by ACT.
Yes.
And divided by A into T. Now, which term cancelling out? This A is cancelling out with A. This T is cancelling out with T. Now the intensity is given by. Can you tell me what is this value? Half epsilon naught into E naught square. This is basically the energy.
Energy. Yeah.
This is the energy of the electromagnetic wave, energy density of the electromagnetic wave.
Yeah.
And this is C. Okay. So
Okay.
basically, intensity of the electromagnetic wave is given by this formula. U into C. What is U? U is the total energy of electromagnetic, energy density of electromagnetic wave. So this is the energy density of
Electron.
electromagnetic wave. And C is the speed of light, or you can say this is the speed of light,
Yeah.
or you can say this is the speed of electromagnetic wave in that vacuum. The speed of electromagnetic wave in vacuum, free space, or air. So I am writing free space. And basically this U is the average value. This is the small u and this is the capital U.
Yes.
There is a difference. There is a difference. So question on this topic. Now this time see a floodlight
Yeah.
is covered with a filter. A floodlight is covered with a filter that transmit the red light. Okay. The electric field of that emerging beam is represented by the sinusoidal plane wave. Okay. So electric field of that electromagnetic wave is given by this.
Yeah.
They are asking, basically here this is not given that this is a electromagnetic wave, but in a wave if there is an electric field, okay, oscillating electric
Okay.
field, so in which wave there is a oscillating electric field? In electromagnetic wave, so basically this will be
Yeah.
the electromagnetic wave. So
Yes.
equation of electric field is given. So in which direction the electric field?
Oh.
From the equation you can tell each and everything about the
Yeah.
electromagnetic field. So this is Ex, means the
Yeah. X.
electric field is oscillating along X
Yeah.
direction.
X. X.
Now can you tell me in which direction the wave is propagating?
The positive X direction.
No, no X, not X. Here is Z.
Okay. Yeah.
Not always I have told you the wave will
Yeah.
propagate along the X direction. It can
Yes.
be along the Z, it
Yeah.
can be along the Y also.
Yeah.
Okay.
So positive Z direction.
Yeah, positive Z direction.
Yeah.
Wave propagation is positive Z. This is not asked, but just for the interest, I am just telling.
Yeah.
So basically, this will be E naught.
Yeah.
Okay. Now, can you tell me what will be this value?
Omega.
No, I have told you omega will always be with T. So this will be omega,
Yeah. Okay.
and this will be
K.
K.
That will be K. Yeah.
But there is no requirement of all these things. Just I am telling, we have to find the intensity of the beam. Basically, this beam is of electromagnetic wave. Okay,
Yeah.
this beam is of electromagnetic wave. So what is the intensity of the electromagnetic wave? I is equal to energy density of the electromagnetic wave into speed of the light.
Yes.
So what is the energy density of electromagnetic wave? Half epsilon naught into E naught square
E naught square. Yeah.
into C. C.
Hmm.
So simply there is no requirement of K and Z, K and omega. Just I have told, but there is no requirement in this question. We can directly
Okay,
solve.
sir.
Now you can solve half. Epsilon naught is 8.85 into 10 to the power minus 11. E naught square is 20 square
20. Yeah.
into speed of light is 3 into 10 to the power 8 meter per second. So
Yes.
finally you will get answer 0.53 joule per meter square per second. So this will be your answer. So there is one another thing, very small topic, relation between the power and the intensity. Basically, intensity is energy. It basically is an energy crossing per unit area per unit time.
Yes.
Energy crossing per unit area per unit time. What is power? Basically, power is the energy crossing per unit time. Energy crossing per unit time. So power can be written as an energy divided by time. So energy divided time will become power. So intensity is equal to power divided by area. So this is the simple relation. After that, the last topic is the electromagnetic spectrum, and that is very important topic. Now, this thing you have completed. Energy density of electric
Yes,
field
sir.
you have completed. Okay.
Yes.
Energy density of magnetic field is also completed. Total energy density you have completed.
Yes, sir.
Completed na?
Yes.
Total energy density. This I think you have taken the screenshots or not?
Yes, sir.
Are you sure? Let's check.
Yes, sir. Yeah. I took.
Took na?
Yeah.
Okay. So, and this question we have done also. This question also means screenshots.
Yes, sir.
Okay. So write down this now.
Okay, sir. Done, sir. Done, sir.
Screenshot.
Yes. Done, sir. Done, sir.
Now there is one more topic: momentum of the electromagnetic wave.
Yeah.
Momentum of electromagnetic wave. So there is a hypothesis that is known as the de Broglie hypothesis that we will study in the earlier chapters in modern physics. According to the de Broglie, the wavelength is equal to the Planck constant divided by the momentum. Okay, Planck
Okay,
constant
sir.
divided by the momentum. So from here we can just write momentum P is equal to h y lambda. So suppose this is the equation number 1. Now
Yeah.
if there is a wave, this is the wave having the frequency f, speed of wave is c, and lambda is the wavelength. Lambda is, what is f? F is the frequency,
Yeah.
and c is the speed. So there is a relation between the speed of the wave, frequency, and wavelength. C is equal to f lambda. C is equal to f lambda.
Yeah.
Now from this equation you can find lambda. Lambda will become c by f.
Yes.
Okay.
Yeah.
So basically, there is one more relation between the energy and the just wait.
Okay, sir.
Okay, so okay, Ziyad. So this thing, according to the de Broglie, uh,
Yeah.
lambda is equal to h is known as the Planck's constant. Max Planck is the name of
Yeah.
the science. All the things
Yes.
you will just study in the modern physics. So
Yes.
from here, momentum can be written as h by lambda.
You got
Okay, momentum can be written by h by lambda. Okay, so
Hmm.
now energy. Basically, there is one more way in with the help of that we can find the energy of the electromagnetic wave. Energy of the electromagnetic wave is given by h into mu or h into frequency. Okay,
Okay, sir.
h into frequency. Okay.
Hmm.
Now this is the energy. Energy of the electromagnetic wave is equal to the Planck's constant into frequency. Okay, now there are different way you can find the value of the Planck constant from here, p lambda, and you can put here, and accordingly you will get the momentum. Okay.
Yes. Okay.
Now what you have to do, basically do one thing, just remove it. We are making it easy. So basically we will find the value of frequency here from here. Frequency is given by c by lambda. Okay, so now
Okay.
put the value of the frequency in this equation here. So u is equal to energy is equal to h. In terms of the frequency, what can I write? C by lambda.
Yeah.
C by lambda. And what is h by lambda? H by lambda is momentum. So h
Yeah.
by lambda we can write momentum into c. So this will be the new formula, new expression for the momentum. What is u? U is the energy and p is the momentum. Already written all the things here.
Yes.
So basically three equations we have used. First equation I have used this. Okay, this is not the first equation. This is the first equation, de Broglie hypothesis. This is the another second equation. The speed of the wave is given by frequency and lambda. And there is
Yes.
third equation, the energy of the electromagnetic wave. Energy of the electromagnetic wave is given by Planck's constant into frequency of that wave. Okay, so this is the momentum, and momentum now, if you want to just find the value of the momentum from here, basically it will become u is equal to hy lambda is momentum into c, momentum into c. So momentum of the wave, you can find energy divided by the speed of the light, or you can say speed of the electromagnetic wave in vacuum. So this is the momentum of the electromagnetic wave. And after that, okay, so first take the screenshot, then last topic we will discuss. So basically this is momentum of electromagnetic wave.
Then
Then okay. Electromagnetic spectrum is purely theoretical topic. Basically, total theory is there. In electromagnetic spectrum, basically what you have to remember, that electromagnetic wave consists of X-ray, gamma ray, and all that thing. And you should know what is the increasing order of frequency, what is the decreasing order of wavelength, what is the increasing order of energy, and you should know what are the uses of the electromagnetic wave, and you can also learn what from which source the different type of the wave like X-rays, gamma rays, microwave, infrared wave are produced. So basically electromagnetic spectrum is the arrangement of the electromagnetic wave in the increasing or decreasing order of wavelength or frequency. That is known as the electromagnetic spectrum. So basically this is the purely theoretical topic. Basically this is the electromagnetic spectrum. Electromagnetic spectrum, the orderly distribution of electromagnetic wave in accordance with their wavelength or frequency is known as the electromagnetic spectrum. So basically we have in electromagnetic wave, we have the gamma ray. Gamma ray is an electromagnetic wave.
Yes.
X-ray, ultraviolet ray, visible. What is the meaning of the visible? This visible is the Vibgyor.
Yeah, the light
Visible.
The sunlight. Yeah.
Yeah. Visible is the Vibgyor. Vibgyor means
violet, indigo, blue,
yeah,
green.
So you know na what is VIV? I think you know.
Yes.
So this is the light that we are able to see.
Yes.
This is the light in the visible range. So this part of the electromagnetic wave we are able to see. And after that, what is IR? Infrared ray,
Yeah.
microwave, and radio wave.
Yes.
So when you are moving from gamma ray to radio wave,
yes,
the wavelength is decreasing.
Yeah.
So wavelength decrease. Okay. And when you are moving from radio wave to gamma ray, the energy is increasing, and energy is Planck's constant into frequency. So Planck constant is a constant, so energy is directly proportional to frequency. So you can say frequency will also increase.
Yes.
So can you tell me when you are coming from gamma ray to radio wave, frequency will increase or decrease?
Frequency will decrease.
Fine. Here, when you are moving from radio waves to gamma, basically gamma ray is having highest frequency or highest penetrating power.
Yes.
If you are taking a steel plate of this much thickness, that gamma ray can penetrate that also.
Yes.
very high energy and frequency. So basically here the frequency is increasing.
Yes.
Basically frequency and energy are directly proportional. So if the frequency will increase, then energy will increase. So now we will discuss one by one the uses, the wavelength range, and the use and the source from which they are produced. So first is gamma ray. So
Yes.
basically gamma rays wavelength range is less than 10 to the power 3 nanometer, and source, from what source the gamma ray is produced? Gamma ray is produced by the radioactive decay of the nucleus. The radioactive decay we will study in the modern physics. So basically the gamma ray have the maximum frequency and the minimum
Yeah.
wavelength. What are the main uses of gamma ray? So with respect to the frequency, gamma ray have the high frequency, very high energy. So due to the high energy, they have strong penetrating power, I have told you.
Yeah.
Hence used to kill cancerous cells. Okay, this thing you
Okay.
have to remember. And basically other use to preserve food stuffs for a long time, because soft gamma rays can kill microorganisms. Do you know what are microorganisms?
Mm,
Like
yeah.
bacteria,
Yeah.
virus,
Bacteria. Yes.
bacteria, virus, these all kinds of things.
Hmm.
Okay, so after that we have the gamma rays, we have the x-rays. We have seen the
Yeah.
x-ray of bone.
Yeah. Yes, sir.
X-ray. Sometimes
Yes.
you have heard
Yeah.
doctor told do the X-ray of this portion of your body.
Yes, sir.
So that are the X-rays. That are the X-rays. Basically, wavelength range is this 10 to the power minus 3 nanometer to 1 nanometer. And what is the source from where the X-ray is produced? X-ray tubes or inner electrons. Okay, this is the
Okay.
source. What are the main uses? These uses the examiner will ask you mostly in exam. So main
Okay.
uses of X-rays is medical diagnosis. Medical
Yes.
diagnosis, because X-ray can pass through flesh but not through bone.
Hmm.
Okay,
Okay.
so the X-ray has the ability to not pass through bones.
Yeah.
If that X-ray will just fall on the bone and there will
Hmm.
be fracture somewhere in the bone,
Yeah.
then
Yes.
that will be detected by the X-ray.
Yeah.
And another use in the study of the crystal structure. If you want to see the internal structure of any material, then we can use also X-ray.
Yes, sir.
After that, the ultraviolet rays. So
Hmm.
ultraviolet rays uh, having the wavelength range 1 nanometer to 400 nanometer. Source inner shell electron in atom moving from one energy level to lower energy level.
Yeah.
Okay, if there are cells inside the atom and the electron moves from higher energy level to the lower energy level, moves na?
Yeah.
So
Yes, sir.
when this happens, the ultraviolet rays produced. And what are the main uses? In food preservation, as it has uh, lethal effect on microorganisms. So this also can just kill the microorganism. And after that, we have the visible light. Visible light is violet, indigo, blue, green, yellow,
Yeah.
orange, red. So
Yes,
visible
sir.
light is produced. Wavelength range is this, and source electron in an atom emits light when they move from one energy level to another. So this is the source. Uses of visible light: stimulate nerve ending of human eye. Okay,
Okay, sir.
and after that, infrared waves. Infrared waves is basically also known as the heat radiation. So wavelength range is this. And what is the source of, what is the meaning of the source? From what the infrared waves are producing? So vibration of atoms and molecules. What are the main uses? They are not scattered in fog or smoke, so they are useful for infrared photographs or haze photography. Means in smoke, if you want to capture the photo, then
Yeah.
infrared rays will be used.
Yes.
Microwaves is very famous. Microwaves. Have
Yes.
you seen microwave oven?
Yes, sir.
Basically, microwaves are also used in the radar communication. So
Yes.
microwaves have the wavelength range this, a very large wavelength range. So due to that, uh, these are used in the radar communication. And what is the source? There is a magneton valve, and that magneton valve is a semiconductor device. This is a source. Okay, so main use is the radar communication. After that, the last is the radio waves. So radio waves is used in radio communication, radio signal. Okay, and
Yeah.
this radio waves have the highest wavelength and the lowest frequency, and the wavelength range is greater than 0.1 meter. And what is the source? Rapid acceleration and deceleration of electron in areas. Okay, and
Okay.
main uses is radio communication. Now I am just showing you how the question will be asked in the exam. So these are the previous year question I have taken. So first question they have asked in some year, I don't know. What do you mean by the electromagnetic spectrum? So this can be solved. Electromagnetic spectrum, if they will ask, then you will write this definition: the orderly distribution of electromagnetic wave. Okay,
Okay.
and after that, if they will ask which of the following has the shortest wavelength, which of the following has the shortest wavelength? So from this order, na, you can
Yeah.
easily crack this question from this
Mm.
order. Shortest wavelength. Okay.
Okay.
Okay, so wavelength is decreasing. So basically, microwave will have the shortest wavelength. So the microwave. They are saying which part of the electromagnetic spectrum has the highest penetrating power? Gamma rays.
Yeah.
Highest penetrating power.
Yes.
Okay. Gamma ray has the highest frequency, and I have told you highest penetrating power also. Gamma rays. You can see here also due to strong penetrating power. So gamma rays has the highest. So these types I want to show you how the question will be asked related to the. And last question you will answer this. Which part of the electromagnetic spectrum is used in radar system?
Microwaves.
Very good, microwave. So these types of questions can be asked related to the electromagnetic spectrum. And this
Yes.
electromagnetic spectrum is basically the important topic. Okay, from the 12th point of view. Okay, from the CBSE 12 point of view. So basically you have to learn basic uses.
Mm. Okay.
Okay, so now you can just take the and in the just there is one more topic, properties of electromagnetic wave. Basically this already completed when we
Yes.
have done electromagnetic wave has a transverse nature, electromagnetic wave had this speed. Okay,
Okay.
and the electromagnetic, what is the direction of the electromagnetic wave? Electromagnetic wave travels in free space with the speed of light. So all these things I have already told you. And in electromagnetic wave there is the oscillation of electrical and magnetic field. So again and again we will not write. Okay,
Okay.
so just note down.
Done, sir. Done, sir.
Okay, so momentum, electromagnetic spectrum. So take the screenshots. Just a minute.
Done, sir.
Done. Okay.
Done, sir. Done, sir. Done, sir. Done, sir. Done.
Done.
Yes. Done, sir.
Okay, so this is the end of this chapter. In the next class, we will start the optics.
Yes. Okay.
So basically, just I want to tell you why we have just studied the electromagnetic wave. Here, the After this, we will study the optics. Basically, optics is a phenomena of the electromagnetic wave. Light is an electromagnetic wave.
Yeah.
So before the reflection, refraction, diffraction, polarization, interference, these phenomena we will study later. So these are the phenomena due to the light, and light is an electromagnetic wave. And before that, we should have knowledge what is the electromagnetic wave. That is why the NCRT uh, introduced this chapter. Okay, and after
Okay.
that there will be